Welcome to our next lesson in the module on classes in Java, where we continue to refine the account class files and objects we created in the previous lesson and polishing our implementation. After completing this lesson, you'll understand how to apply abstraction principles to hide low-level implementation details from client programmers by creating accessor and mutator methods your clients can use to interact with the class. You will also know how to create our own constructors, which will streamline the creation of objects in client files. To begin this lesson, be sure you have launched Android Studio and open up both the client program and the class file. When we left our account client program, it wasn't working. We hadn't made any changes to that file, but we had made changes to the account class file, a file that our client program was using. Making instance variables in a class private is a good practice, but now we need to modify the rest of our class to accommodate these changes. We see two types of methods in a class: accessors and mutators. Accessor methods are used to access data from outside the object. Usually they are very simple methods that return a value. Mutator methods are methods that change or mutate the value of a field. The method may simply overwrite the variable with some new value. These are often called set methods. It could be something more complex, though, like our withdrawal method that performs certain checks and changes data in some way. Here are some examples of calls and codes for both types of methods. This code may be found in a client method. This is how we should now access a field like name. Here are two mutator method calls you might see in a client program. The first one is simply writing over the value. This is a typical set method. The second mutator will change the value using addition. Code for a simple get method is shown here. This is the kind of method we need to add to our account class for each of the fields we have just created as private. Code for the set method is also very basic, while code for other mutators may contain some very complex tasks. Pause this lesson now and update your account class to reflect some of what we have learned here. Add accessor methods for all of our fields, but only add mutator methods for name and number. We may allow accounts to be reassigned, but we still don't want users overwriting their own balances directly. Your client program should look something like this. Notice how we are creating an object, then filling in the fields. We can combine these two operations into a third type of method used in a class file, the constructor. Constructors are used to create new objects from class files, and you've already been using one, the default constructor. We usually create an object in one line, beginning with the name of the class for which we are creating an object, then the object name, followed by the keyword new, and a call to the constructor method. Notice that the name of the constructor method is always the same as the name of the class itself. But the constructor method is followed by parentheses, like all methods are. Creating an object really takes two phases, which can be seen better here, where we have opted to use two lines of code to create the object. The first line of code creates the reference to the object, but in actuality, no object has been created in memory yet. The second phase creates the new account object and causes the variable to point to it. Notice also, this object's fields are all set to default values. Our client file uses this default constructor, but we never wrote it in our account class. That's one of the reasons it's called the default constructor. It is created by default. We don't need to do anything. It comes free with the creation of the class. We can also build our own constructors, however. A constructor can have input parameters. These parameters can then be used to initialize some or all of the fields as the object is being created. But there is a caution. Once you begin writing constructors of your own, the default constructor goes away. If you want it, You're going to have to rewrite it for yourself, along with other constructors. Here is the syntax for two different constructors. The first one would be used to create an account and set the name and number. Since we didn't initialize the balance, that would still be set to the default value of 0.0. The second constructor will initialize all three instance variables. All constructors must have the same name as the class itself. They are usually public, and they never have a return value. This is how we can recognize them as constructors. Calls to these methods would look like this. Notice that both constructors have the same name but different parameter lists. This is an example of overloading a method. The compiler will recognize which constructor you are calling by the parameter list. Pause this lesson and add two new constructors to the account class file. One that sets just the name and number field, and another that sets all three fields. Each will use their input parameter lists as the source for the data. Once they are written, take a look at your account client program. Can you figure out what's going on here? Your account class file should look something like this. But what's causing the errors in the client program? We are still using default constructors, but recall that constructor doesn't exist anymore. Not since we started writing constructors of our own. There are two fixes for this. Rewrite the default constructor in your class file, or use the new constructors to set variables while you're creating the object itself. Pause here and modify the account client program. We will forgo writing the default constructor for now, and instead use the new constructors in our client program. This should remove all of the errors from your client program, and it should run again. Writing a class file and a program file at the same time can be maddening. Without making any changes to a client program, errors can suddenly pop up. This is often due to some change made in the class file that now requires a change in the way that class file is used. But it won't always be this way. You may find yourself writing classes to be used by other programmers. Or you may be writing a client program that uses a well-developed class, one that isn't expected to undergo changes while you are writing the client program. In all these cases, you should begin to see how important it is to take some time to plan your design before you dive in and begin programming. In this lesson, we are designing as we go so that these errors will be created purposely. Creating and resolving these errors for yourself is not only a good way to learn about classes in Java, but it should help you to gain a deeper understanding of why the code works the way it does. It's time to start taking advantage of code that has already been written. Here is a good example. Notice that assigning values to name and number is done in both constructors. We should save some coding by starting out with the first constructor, and then simply adding on the code to initialize the balance. Here is how we can do that. To refer to a constructor in our own class, we use the keyword this. Let's take a closer look at what's going on here. The client makes a call to the desired constructor. In this case, the constructor that will initialize all three fields. The data from the parameter list is passed to that constructor. The name and number data is then passed to another constructor, which will create the object and set the two fields. Then, the originally called constructor continues by initializing the balance. There is a rule concerning calling one constructor from another. But if we can understand what's going on, it is a rule we can understand, and therefore we won't need to memorize. When we call another constructor, we are in essence passing off the work of building an object to the called constructor. Here we see the object is created and variables are initialized. Then any other code from the originally called constructor is executed, using this newly created object. For this reason, the call to another constructor must always come first. Trying it in a different order doesn't really make sense now that you know what's going on. If we attempt to initialize the balance field first, then the object must necessarily be created. When we call another constructor to do the rest of the initialization work, that constructor attempts to create an object as it was designed to do. This would cause all sorts of problems. Luckily, this code ordering would also cause a compile error in your class file. Now that you understand why this ordering is done in this way, you won't soon forget it. Now that you've completed this lesson, you should have a good understanding of not only how to create mutator and accessor methods, but why they are fundamental to the good design of classes in Java. We remove the details of the object from the view of the object user. As long as a client programmer who is planning on using our class knows how to interact with the objects of our class through methods, there is no need to reveal the low-level implementation details, which are likely to change over time. You should also know the ins and outs of creating constructors, such as being able to access the type of constructors you need for a class and to write it in Java. Although we've covered a lot about classes, we still have more lessons to go. To make sure you are ready to move on to the next lesson, I therefore encourage you to do several other things, such as taking the practice quiz and working with the account program to write some constructors and add a field to your class. As you do these things, try to get a better understanding of the relationship between the classes, instantiated objects, and client programs.